This is Algebra Lesson 7-1, 0 and negative exponents. Now let's review a couple of things before we talk about what 0 and negative exponents are. If we took 2 to the third power, to evaluate that, this essentially means that we have 2 times 2 times 2. 2 times 2 times 2 is 2 times 2, which is 4, times 2, which is 8. 1 divided by 4 squared means that's 1 divided by 4 times 4, which means this is 1/16. And letter C says the opposite of 3 squared. It does not say negative, it says the opposite of 3 cubed. It does not say negative 3 cubed. It means the opposite of 3 times 3 times 3, which is not a big deal when it's cubed, but is a big deal if it's taken to an even numbered power like squared or 4th degree, 6th degree, 8th degree. 3 times 3 is 9, 9 times 3 is 27, so this becomes negative 27. Now, recall that an exponent tells us how many times we use a base as a factor. For example, a to the third equals a times a times a. Now let's look at 3 cubed, 3 squared, and 3 to the first. Describing the exponent by 1, decreasing the exponent by 1 is the same as dividing by 3. For example, 3 cubed is 27, 3 squared is 9, and 3 to the first is 3. So if we have 27, then went to 9, and then went to 3, 27 divided by 3 is 9, 9 divided by 3 is 3. If we continue this pattern, 3 divided by 3 equals 1, so 3 to the 0 has to equal 1. And 3 to the negative first means we're dividing 1 by 3, so 1 divided by 3 becomes 1/3. These two examples lead to some very important properties in algebra, and these are just the beginnings of the properties of exponents, which is what this chapter is almost all completely about. Two of these properties, the 0 as an exponent property and the negative exponent property. The 0 as an exponent property says for every non-zero number a to the 0 equals 1. That means 5 to the 0 power is 1, negative 2 to the 0 power is 1, 1/3 to the 0 power is 1. As long as your base is not 0, anything to the 0 power is 1. And for a negative exponent, it says for every non-zero number a and integer n, a to the negative n is the same as saying 1 over a to the positive n. For example, 6 to the negative 4th becomes 1 over 6 to the 4th. Negative 8 to the negative 1st becomes 1 over negative 8. Okay? These are very, very important properties in algebra. Now let's look at why you cannot use 0 as a base, because in both of these instances, they told you that it had to be a non-zero integer base. Okay? So the first property implies the following. If we have 3 to the 0 equals 1, 2 to the 0 equals 1, 1 to the 0 equals 1, 0 to the 0 would equal 1 then. However, the second pattern is here. If we have 0 to the third power, that's 0. 0 squared means 0 times 0, which is 0. 0 to the first means 0. So 0 to the 0 has to equal 0. It's not possible for 0 to the 0 to equal both 1 and 0 at the same time. Therefore, 0 to the 0 power is undefined. So you cannot use 0 as a base with a negative exponent any more than you can use 0 as a base with a positive exponent. Using 0 as a base with a negative exponent will result in division by 0, which is also undefined. So let's look at some simplifications. In algebra, when you are asked to write something in simplest form, it is not written in simplest form if it has negative exponents. It is only in simplest form when it is written with only positive exponents. And that's not something that they have to state. It's something that is implied, and it is now something I'm telling you. If the fraction is a fraction in simplest form, the only common factor of the numerator and the denominator can be 1. So let's simplify a few powers here. Okay, 3 to the negative second. Well, our second property of exponents said that anything to the negative exponent is the same as taking 1 over that number to a positive exponent. So we now have 1 over 3 squared. 3 squared can be simplified. That's 1 over 3 times 3, which means this is 1/9. If you can multiply it out without getting a ginormous number, you should multiply it out. Number 2 here says negative 7 to the 0 power. According to the first property of exponents, anything to the 0 power that is not a 0 base is 1, so this would be 1. Number 3 here says -4 to the -3rd. That means this is saying 1 over -4 to the 3rd power, which is 1 over -4 times -4 times -4, sometimes better put with parentheses than it is with the little multiplication symbol. 4 times 4 is 16, and 16 times 4 is 64, so this is -1 over 64. It doesn't matter where that negative sign goes. It can go on the top number, it can go on the bottom number, or it can go in the middle. As long as one part of your fraction is negative, the entire fraction is negative. Now 4 gets a little trickier, because we're looking at this going, oh, everything needs to move to the denominator. No, it doesn't. Only numbers or variables taken to a negative exponent move down. 3 is taken to the positive exponent, a is taken to a positive exponent. So this is like saying 3a over 1 times 1 over b squared, which ends up to be 3a over b squared. If it doesn't have a negative exponent, it does not move to the denominator. One of the easiest rules to remember is if it's in the top of the fraction and it's a negative exponent, it moves to the bottom of the fraction. If it's at the bottom of the fraction and has a negative exponent, it moves to the top of the fraction. And when it moves positions, it becomes positive. So number 5 here says 1 over x to the -3rd. Well, x to the -3rd is taken to a negative exponent. To make this positive, we need to move this up here to the numerator. So this just becomes x to the +3rd, because anything times 1 is itself, so this becomes x to the 3rd. Number 6 here, 11, m to the -5th. The only thing taken to the -5th power is the m. The 11 is not taken to a negative exponent, so it stays in the numerator. The m to the 5th needs to change, because remember, this is all over 1. M to the 5th needs to go from the top to the bottom, and when it goes to the bottom, it becomes a positive exponent. So this becomes 11 over m to the 5th. Number 7 here. We have 7s to the -4th, t to the 2nd. Okay, remember, this is all considered to be over 1. If it's negative and it's in the numerator, to make it positive, move it to the denominator. Okay, or let me put that in people terms. If it's negative and it's at the top of the fraction, move it to the bottom of the fraction. And if it's negative on the bottom of the fraction, to make it positive, move it to the top of the fraction. You change its positions. So the 7 is positive and the t² is positive, so they stay on the top. The s to the -4th is negative, so it needs to move to the bottom to become positive, so we just put s to the 4th on the bottom. And we are done. Number 8 here. We have n to the -5th divided by v to the 2nd. Well, the n to the -5th is on the top, so to make it positive, I need to move it to the bottom. Well, we have to have something in the top of the fraction, otherwise we can't have a fraction that looks like this. Oh, n to the 5th over v squared. What's n to the 5th v squared? Remember, if we move this to the bottom, we have to replace this with a 1, because we have to have something in the numerator of our fraction. Okay, because remember, this is n to the -5th. Is like saying 1 over n to the 5th, and we're multiplying that by 1 over v squared, so it becomes 1 over n to the 5th v squared. And I normally put my letters in alphabetical order when I write the answer, because that's typically how it is done in algebra. So I will write my answers that way, I will read my answers that way. Get in the habit of doing that, because when we get into chapter 8, you will have to do that, because that's what standard form is. All right. Now, when you evaluate an expression, you can write the expression with positive exponents before you substitute in values. I find it to be much easier to do that way rather than plugging in all the values and then trying to move all the numbers, because then we get lots and lots and lots of numbers. So in all these 4 examples, I'm going to make all the exponents positive before I have put in n equal -2 and w equaling 5. Okay, so if we have the first problem here, number 9 says n to the -3rd, w to the 0. Right? Anything to the 0 power is 1, and this is all over 1. This needs to move to the denominator to become positive. So w to the 0 is 1. This is over n to the 3rd power. Now I will substitute in that n is equal to -2. So we have 1 over -2 to the third power, which means 1 over -2 times -2 times -2, which is -1/8. And remember, -2 to the third is not 6. Please don't fall into that bad habit. -2 times -2 times -2 is 8, or actually -8 in this case. Number 10, to make it positive, the end of the negative first needs to move down. So I have 1 over n to the first, w to the second. And you can leave that 1 off of your n, because it's always an implied 1 when there is no exponent. So n is -2, so I've got 1 over -2 times 5 squared. And remember, whenever you plug in a number for something, you always have to put it in parentheses before you put the exponent on it. Okay, so we have 1 over -2 times 5 squared. Order of operations says we have to do 5 squared first. So this is going to be -2 times 25, which is going to make it 1 over -50, or -1/50th, however way you want to write it. Let's look at number 11. W to the 0 over n to the fourth. Anything to the 0 power is 1, so this is 1 over n to the fourth. And here's how it's really important to make sure that when you put in your variable here, -2 goes inside the parenthesis before you take it to the fourth power. Because now -2 is going to end up to be positive because we have 4 negative signs, and an even number of negative signs means it changes to positive, because this now says 1 over -2 times -2 times -2 times -2. Right? Which becomes -2 times -2 is 4, -2 times -2 is 4, 4 times 4 is 16. This is 1/16. And the last problem in this set, 1 over n w to the -2. This w to the -2 needs to move to the top in order to be positive. So this becomes w to the 2nd over n. So this becomes, now we're going to substitute in, so we have 5 squared over -2, which ends up to be 25 over -2, which I'm just going to leave as an improper fraction because that's perfectly fine. I'm not going to change this to -12.5 because it can be perfectly fine as -25 halves. Now we also need to be able to do problems that deal with word problems. Okay? So if I have an exponential expression, it says a population of birds doubles every 8 years. The expression models a population of 6,400 birds after t periods of 8 years. Evaluate the expression for t equals 0 and t equals -2, and then describe what each value of the expression represents in the situation. All right, so if we have the problem which says, oh, my expression got out of here. The expression, it messed up my expression. It's supposed to be 6,400, sorry about that, 6,400 times 2 to the t power. That should have been in this particular part of the problem. It somehow got left out. So my expression is 6,400 times 2 to the t power. So 6,400 times 2 to the t power. And we're going to solve this for t equaling 0 and t equaling -2. And then we're going to explain what each one of these represents. So here I'm going to have 6,400 times 2 to the 0 power. Anything to the 0 power we know is 1. So 6,400 times 1 is just 6,400. T equaling -2 means I have 6,400 times 2 to the -2nd power, which is 6,400 times 1 over 2 squared, which is 6,400 times 1/4, and 1/4 of 6,400 is 1,600. So 6,400 is when t equals 0, and 1,600 is when t equals -2. But what do those numbers represent? Okay, well, if t equals 0, that means 0 periods of 8 years. which means now. It means the current population of birds is 6,400. Okay, so we're going to write that. The current population of birds is 6,400. Now, when t equals -2, that means 2 periods of 8 years ago. So 2 periods, excuse me, 2 periods of 8 years ago means 16 years ago. So that means the population 16 years ago was only 1,600 birds. And I'm abbreviating population because I don't want to write it out. That's what this particular expression is meaning. It means that right now the current population of birds is 6,400. 16 years ago, which would be 2 periods of 8 years ago because it's negative, they only had 1,600 birds, which means that the birds are multiplying faster, which means either they've stopped hunting the birds or the natural predator to the birds is not as active as it used to be and the birds are flourishing. Okay. Our closure question for today. Describe the property of negative exponents in your own words. So in other words, what does the property of negative exponents say? Please do that in your own words. Don't use the same words that I used to describe it when I did the video. Try to put it in your own words.